Hi, everyone. Welcome to today's webinar, From Pain Point to Pipeline, a practical guide for data engineers. And I'm here with my colleague, Fahim Javid, and he is going to take you through today's session. And we thank you so much for joining us because we know everyone has a lot going on, and we're really grateful that you're here for this hour-long session. All right, we're going to get started in just a moment. Just to let you know, there is a chat feature. So if you've got a question or if you have any issues, you can go ahead and just put anything that you need in the chat. And this session is being recorded, and we will send you the video afterwards. So you don't have to go crazy trying to take notes if you don't want to. I mean, you can, of course, if you want, but you will have this recording for you afterwards. All right, let's get started. Well, welcome. My name is Anne, and I'd like to welcome you to this session on behalf of Ascendient Learning. We are the experts in instructor-led technical training, and we are so happy to announce that we are also part of Accenture LearnVantage. Now, this is fantastic news for you because not only do we still have our latest certifications and our award-winning instructor-led training, we can now offer a full life cycle of IT training, including self-paced courses, always private training, but also one-on-one mentoring and customized learning journeys and consulting for your entire life cycle. We still offer the same personalized white glove service, and we still have our wonderful trainers who absolutely love what they do. And speaking of wonderful trainers who love what they do, I would like you to meet Fahim, who is going to be your instructor for today's session. Fahim is a true expert. He's not only a Microsoft certified trainer, but he is an expert in all things data, data science, data analytics, business intelligence, AI. He's worked extensively with Microsoft Fabric, all things Azure, pretty much anything data related in the Microsoft ecosystem he knows about and he's used. He's been a full stack developer since the 90s. I could rattle off all the certifications he has, but he probably has every single one related to Azure Data and Microsoft Fabric. But beyond that, beyond the credentials and all the experience, he's actually a wonderful instructor and a great communicator. He's got over 27 years of experience teaching the official Microsoft curriculum, but he also writes, develops, and teaches his own courses that can sometimes fill in gaps that maybe the Microsoft official course didn't have. One other thing he's really great at is if your team's not really sure what they need, he listens and he can pinpoint and say, okay, these are their courses, certifications, and here's some extra courses that you might need just to make sure that you get a well-rounded education. And speaking of well-rounded education, after the session, if you would like to dive a little bit deeper into any of this material, we do offer Microsoft official courses that can lead to certification. So on the screen, everything that says DP, those are the official Microsoft courses, and we teach a lot more than that. We'll give you the full list in the email that we send out after this session with the recording. But that last one that starts with WA, that's a course that Fahim wrote and developed that can fill in some of the gaps that maybe the Microsoft course doesn't cover, and he's also really good at customizing anything you need in that way. So you are in excellent hands today. And with that, I will go ahead and stop my share and send this over to Fahim, who will dazzle you with data. There we go.
Thank you, Anne. Thank you for the great intro and making the job easier for me. Okay, so greetings, everyone. Anne has already introduced me, so I won't bother adding anything to it. She has added quite a bit to it already. Okay, today's session is about data engineering. So we will discuss what exactly data engineering is and what are the different options available on the Microsoft ecosystem or as part of the Microsoft ecosystem and whatnot. And then we will also touch on the different ways you can use to design your data pipelines. And before we discuss any of the stuff, overall, the goal is to talk about some of the traditional stuff first. So what exactly used to be the old way of doing things. So what's the new evolution or evolutionary way of doing things? So the modern data ecosystem that is provided by Microsoft. Then we will talk about the different services or solutions available to us, and then deciding what solution we should go with. And then after that, I'll touch on building and managing data pipelines as well. Okay, so before we discuss this in detail, I would quickly ask a question. So in the chat window, you can quickly type in the answer. So you can mention your role. Are you a data analyst, data scientist, or data engineer? Or you do a bit of everything? Mostly, I'm expecting data engineers today, since that is the title of the webinar as well. But still, at times, usually people wear multiple hats. So sometimes people are data analysts as well as data scientists, and at times they also do a bit of data engineering as well. So if you want, you can type in the answer in the chat window. That is up to you. But overall, the purpose of this session is to focus on data engineers. Okay, thank you, appreciate it. Then next, let's talk about the evolutionary way that is provided by Microsoft. And before we discuss the evolution or the evolutionary way, let's quickly talk about the old way of doing things. So what is the traditional way of doing things, so that we can understand some pain points. So the goal is to experience some pain and then talk about the new stuff, which helps us in modernizing our systems. So the old way of doing things with data used to involve limited data sources. So maybe we used to have Excel workbooks, maybe we used to have CSV files, and maybe we used to have SQL Server databases back in the day. And in fact, there are companies who still use all of these technologies. And yes, it's good to have all of these technologies. So these technologies are not going anywhere at all, but we should not limit ourselves just to these technologies. So back in the day, when it came to designing our data-based solutions, we used to have mostly just these sort of data sources. And then also back in the day, we used to have smaller data volumes, maybe a few 100 MB, like back in 1983 or 84 or so. Bill Gates mentioned that I do not envision anyone using more than 640 kilobyte of data, 640 KB. Can you imagine not having more than 640 KB of data? Obviously, no. So these days we have not even terabytes, but petabytes of data. So back in the day, we used to have smaller data sets. At best, people used to say that we have around maybe a gigabyte of data, or if you have a very gigantic sort of company, back in the day, we used to have around 50 GB or something like that. So typically, it didn't used to be more than that. So traditionally, we used to have smaller data, less variety used to be there, and it also involved simpler data processes. So data ingestion, data transformation, data manipulation, data cleanup, cleansing, etc. It used to be much simpler, straightforward, because we had smaller data sets and very limited data sources and destinations. So that used to be the old way of doing things. And the modern way, before we touch on that, let's also discuss one more aspect of the traditional way of doing things, and that is the roles that used to be involved back in the day. So traditionally, in our business intelligence scenarios or solutions, and business intelligence overall basically means solving problems by asking questions based on your data. So you have your data, and you want to ask different questions: who, what, where, when, why, how, and whatnot. Overall, that is part of dimensional modeling, and we do have detailed courses where we talk about dimensional modeling in much more depth. But typically, business intelligence involves asking questions: who, what, where, when, why, how, based on your data, and then making meaningful decisions based on that data. So business intelligence wise, uh, especially back in the day, we only had two main roles. So we used to have business intelligence developer or BI developer, and BI developers were responsible for the data ingestion part. Like you can have maybe your CSV files, you can have your Excel workbooks, you can have your SQL Server databases as well. And you take your data, you clean it up, transform it, uh, modify it, and then you can store it in some other data warehouse, something I'll touch on afterward. But you can have a data warehouse, and then your report designers can connect to it by using traditional tools such as Excel, or you can also utilize SQL Server reporting services, report builder. So all of these are traditional sort of tools. So we used to have this much simpler process. But these days, we have more roles involved. And before I touch on those roles, for now, just know that we have the BI developer role, and BI developer is responsible for the data ingestion, like reading data from different data sources, cleaning it up, storing it, organizing it, structuring it, modeling it in our data warehouse, and then your data analyst can connect to it. And talking about data analysts, we have the report designer role, and that is where you can use tools such as Excel. You can use, these days, obviously we use Power BI, but back in the day, we didn't have Power BI. Instead, we have Report Builder. We had SQL Server reporting services, Business Intelligence Development Studio, SQL Server data tools, Crystal Reports used to be the older tools. So in short, back in the day, things used to be somewhat simpler. We had the BI developer role and report designer role. And you can also involve the DBA role, who usually sets up, let's say, SQL Server databases, Oracle databases, and whatnot. So you can see that overall, we have very few roles involved here in the traditional way of doing things when we had to implement business intelligence. And overall, back in the day, we mostly had static reports. You had to manually refresh the page to see the up-to-date data, or even when you refresh the page, at times it doesn't show the up-to-date data right away. Instead, it is scheduled refresh. So usually reports, they were, especially back in the day, they were refreshed periodically. Like maybe at midnight, you can refresh your data warehouse, and then your reports can get the up-to-date data and show you the latest data and whatnot. So typically, reports used to be static back in the day. Even these days, some reports can be designed in a static manner where you don't need to refresh data in real time. But especially back in the day, it used to be scheduled. These days, we have lots of options available. And that is what we will discuss in just a bit. What are the new options available that we should be aware of? As a data engineer, you should be aware of all of the new techniques. And we will discuss that in just a bit. But overall, we used to have static reports, and data was processed in sort of batches, like at midnight, once a day, every maybe couple of hours, once a month. So depending on whether you have monthly reports, weekly reports, daily reports, hourly reports, you can choose to refresh your data accordingly. So that is also known as batch-oriented data processing. So overall, we had legacy, old technologies involved. And typically for business intelligence, we used to have SQL Server reporting services to design reports, SQL Server integration services for the data ingestion, data cleansing, data transformation part. which was used by data engineers. And then for data warehousing purpose, we used to have SQL Server analysis services like cubes, multidimensional databases, tabular data model databases, and whatnot. So if any of you have used these older technologies or you have these at work, awesome. If not, skip it. Just know that we are going to touch on the latest approach, the more up-to-date modern approach that you should be aware of, like how you're supposed to engineer your data. Okay, so this is the old way of doing things. This is the last slide I'm going to show you on this old way of doing things. After that, it will be all modern stuff. So the old business intelligence way of doing things involved some data sources like SQL Server, Oracle, maybe Access, Excel, CSV, XML, and whatnot. And then we utilized SQL Server integration services to connect to these data sources, clean up the data, transform it, shape it, add columns, remove duplicates, check for data types, find out if you have missing values. So clean up your data. And then store it in your data warehouse, which is like a consolidated database. So everything is now centralized here. And then after that, we used to have SQL Server analysis services, where we used to perform the slicing and dicing of the data, where we used to create these cubes, analytical cubes, where data was aggregated and then broken down by different attributes, measures, and whatnot. And then we did have the data mining, the machine learning sort of feature back in the day, which allowed us to search for data in an intelligent manner. So we used to have the data mining process available in the SQL Server analysis services based component. And then after that, we used to connect to it from Excel. So reports wise, you can use Excel. You can use SQL Server reporting services, report builder, or any other technology of your choice, connect to your cubes, and then start creating your reports. So data engineers were primarily involved in this area. Even for the cubes manipulation, processing of the cubes, it was the responsibility of the data engineers. And then report designers, they were allowed they were asked to just connect to the existing cubes and create reports. And actually, this diagram or screenshot brings back some memories. Like I created this one back in 2005 when business intelligence was still a very new concept. New technologies were introduced as part of SQL Server 2005. But if we compare it to what we have available to us today, this is now obsolete. So this is now pretty much obsolete. Concepts are applicable, but technologies and tools are radically different. So that is where we are going to talk about the new stuff, the modern data ecosystem. And before I show you some demos and show you some of the stuff practically as well, let's talk about what's really there in the new stuff. What has changed in the new stuff? So in the new systems, we have 3 V's, velocity, variety, and volume. Maybe let's start off with volume. So gigantic data sets, several terabytes or even petabytes of data is now available these days. So think of maybe Facebook, Twitter or X, the new name, X, or any other modern technology, including the IoT devices as well, Internet of Things devices, security equipment, home appliances sort of equipment, sensors can be there that can produce data every second. Hundreds of records can be produced almost every second. So when we have insane amount of data, the volume is just too much. Usually we say that it is big data. So big data is gigantic. So when we have huge amount of data, processing wise, we cannot rely on the old way of doing things, which only involves a single local machine. So your local server, local machine, it has a finite amount of let's say resources available to it, like the amount of RAM, the number of CPUs, everything is finite. So the processing power is not really there in our traditional local infrastructure to process huge amount of data. And for that matter, even to store huge amount of data, we cannot rely on the old way of doing things. Secondly, variety. So yes, we still have CSVs, we still have XML files, we still have Excel workbooks, we still have SQL Server databases, we still have Oracle. But on top of it, now we have more data sources available to us. So for example, we have real-time data available to us. So we usually use something called event-driven architecture, where events produce data and you want to make sure you are able to process the data in real time. So event-driven architecture, real-time data processing. As an example, think of maybe Uber. So Uber Ride, Uber Eats. Hopefully it's almost lunch time for some of you folks, or dinner time, or it doesn't matter what time it's there. So you might end up eating something. So Uber Eats, let's say. So you want to order a meal. So you basically open up the app, and in real time, data is sent and then processed. There's very little latency involved, maybe a second or two. And actually, I'll show you this practically on my site later on. I'll show you a demo where data will be processed in real time. Within a second or two, data will be processed. And you can keep on bombarding it with data. You can have hundreds of thousands of records getting sent, and it will just keep on processing the data almost in real time with very little latency. So when you have the need for real-time data, like Uber, it could be 911 sort of scenario. It could be, let's say, a scenario where you want to make sure that your inventory is restocked in real time. You cannot afford to have batches of, let's say, data processed every 2 hours, 10 hours, once a day kind of thing. You need to process it in real time. That is where you end up using the event-driven based architecture technique. So you have real-time data as well these days. And then you can even have other data sources. So later on, I'll discuss that there is a data source called Parquet, which is very, very popular among data engineers. So Parquet is overall the CSV kind of concept, but unlike CSV, where data is stored row by row, so each record is stored row by row. So whatever the number of columns we have here, we don't care for it, but your overall data is stored row by row in case of CSV. So unlike this row by row storage, Parquet ends up storing data column by column. So it will basically end up storing the entire first column, then the entire second column, then the entire third column. So if, let's say your column name is ID, then we have, let's say, name, and then we have, let's say, maybe department. And later on, you can hypothetically use some queries like this. So select only the name column from whatever your data source is. So when you use the Parquet format, just because your data is stored column by column, it will be possible for us to retrieve only the name column from the hard drive, from the storage. And storage is typically the slowest component of your system. So when you run this query, the Parquet format is capable of getting data only from a specific column or columns of your choice and that improves the performance a lot. So your data analysis performance will be improved a lot if you have data stored column by column. And on top of it, the Parquet format compresses the data as well. So all of this data is compressed column by column. So as data engineers these days, we have to be aware of real-time data sources such as Apache Kafka, Azure Event Hub, Event Grid, and we have a bunch of other technologies. And then we also have Parquet as the storage format. So for now, know that the modern systems, they have huge volume, variety is there. Unlike the old way of doing things where we only had CSV, XML, SQL Server, now we have to worry about real time. We have to worry about compressed storage, faster storage options. So data engineers are responsible for knowing all of the modern stuff so that they can decide what data source we should use to store the data so that our data analysts can process it in a fast manner. And velocity. So every second you could have dozens of records produced. So they can be high velocity kind of scenario where it could be received in real time and then you need to process it. So 3 V's, they represent the characteristics of big data technologies that are available these days. So as data engineers, now we need to upgrade ourselves. We need to be aware of all of these modern techniques as well. Okay, so we know the modern picture. Now, what are the different ways of handling the modern picture? How do you handle a huge amount of data, variety of data, velocity, and whatnot? So that is where we have multiple technologies available. And before I touch on the technologies, these days we have diverse roles as well. So back in the day, we mostly had BI developers and report designers, mostly. In the context of business intelligence, we mostly had these 2 roles. You could involve DBA as well, database administrator, but overall things used to be simpler. But now we have data engineer, data scientist, AI engineer, and then obviously we have data analyst role as well. So data engineers, they are responsible for setting things up, making sure all of the data is organized, structured, stored in an optimal manner so that data analysts can benefit from it. And in fact, if I show you one more diagram here so that it makes sense, I'll keep on using it as sort of a reference kind of diagram. Okay, so I can bring it over here. Okay, so you'll basically end up having something like this. So you'll still have your CSVs, Excel, SQL Server. You can have data on websites. You can have data in some real-time kind of data source, such as Apache Kafka. You can have event hubs, event grids for real-time data receiving and whatnot. So you can still have lots of data sources. And then data analysts will be way over here using some reporting tool. And these days, you can mostly prefer using, let's say, Power BI or Tableau if you want. Otherwise, being a Microsoft evangelist, I would definitely suggest going with the Power BI option. So Power BI users, report designers, although they can directly connect to the underlying data sources, CSVs, Excel workbooks, and whatnot, but we prefer not directly connecting to them. Instead, we have data engineers involved, and they create data pipelines. So data pipelines, which I'll briefly show you practically as well. Overall, yes, you will see that it's a pipeline. So we have multiple stages, they are interconnected stages, and data engineers are able to connect to these underlying data sources, clean up the data, shape it up, transform it, add columns, remove duplicates, remove null values, empty values, replace values, fix data types and whatnot. and then they can store all of the structured, organized data in any technology that's capable of handling big data. And in just a bit, I'll touch on Fabric, Snowflake, Synapse, Fabric and Synapse, and Databricks as well. Otherwise, again, we have this third-party option, Snowflake. So you can use Snowflake as well to organize all of your data here. And the point is that these report designers, they should only be responsible for connecting to this single source of truth. So rather than asking every report designer, hey, we have 500 CSV files, 300 Excel workbooks, 20 SQL Server databases, 40 Oracle databases. Now we only have to ask them to connect to the single source of truth. Centralized data is available here. And data engineers are responsible for engineering this thing. So just like a civil engineer would, let's say, work on bridges and roads and whatnot to fill in the gap in between two different places. So likewise, data engineers fill in the gap in between the data that we already have at work and our data analysts. So they create the single source of truth to organize all of the data, structure it, clean it up, shape it, transform it, so that report designers should only be responsible for connecting to this single source of truth, enterprise data, and not have too many worries about, let's see, how do I clean it up? Do I have to create a ticket? Do I have to ask the IT department to do it? You can basically just expect the cleaned version of the data in this data warehouse. And then your executives, managers, decision makers can view the reports designed by your data analysts. So overall, data engineers are responsible for these things. So number one, where your current data is. Number two, create data pipelines that will end up cleaning up the data, transforming it, shaping it up, and then store it in some central warehouse kind of thing. So data engineers are responsible for this part. Data analysts consume the data, create reports, and in fact, even data scientists, they consume the data. So not that we have it covered in this webinar, we have it scheduled later on, where we will talk about the data scientist role as well. But data scientists, they end up also connecting to the structured, organized data, and they can still choose to connect to the original data as well if needed. And they end up using code in Python, and then they use a Jupyter notebook technology to create their solutions, notebooks basically. And then they can also utilize machine learning for data prediction, forecasting, data segmentation, clustering, etc. So we have a whole webinar scheduled later on where we'll talk about data scientist sort of role in detail. But in short, data scientists, they also consume data. Typically, the data that is structured, organized by data engineers. Otherwise, they can also choose to connect to CSVs by themselves and create their solutions manually as well. And then AI engineers, creating AI models, generative AI models, Gen AI models, large language models, custom models, where you can have your custom documents, custom data in your, let's say, SQL Server and other technologies fed so that your Gen AI model can answer the questions and whatnot. And in fact, later on, I'll mention this technology called Fabric. And Fabric has something called Data Agent. So Fabric has a very good built-in option called Data Agent, which lets you create the AI models based on data available in the Fabric data warehouse. So for now, let's only focus on the data engineering role, but know that these days we have lots of additional roles involved as well. So we'll primarily focus on data engineering role. Later on, we have webinars coming up on data scientist, where we can also touch on the AI engineering concept as well. Okay, so in short, roles-wise, you can see there are lots of roles involved these days. Okay, so now on top of it, on top of all of these existing challenges, we also have one more challenge, and that is compliance requirements. So who should have access to what? What data they can access? Can they view the entire record, or can they view only certain records or columns? Can they view the actual value, or can they only view the partial masked cut down version of the record, like maybe credit card numbers and whatnot? So you can say that we want to mask them, only show the last 4 digits and whatnot. So when we have lots and lots of data sources, so you could have 500 CSV files, 300 SQL Server databases, and Excel workbooks and whatnot. So that is where, on top of your engineered data, we end up using some compliance requirement or data governance kind of technology. So Microsoft offers us with something called Microsoft Purview, which sits on top of your existing engineered data, where we have our data warehouse. And there you can configure your rules, compliance rules. And yes, it can still also be used on top of your CSV files, Excel workbooks, and everything else as well. Or you can choose to use it only on top of this data warehouse or on top of everything. So that is up to you. You can choose to have this purview as well. So as data engineers, know that you will eventually also encounter some data governance technology as well. So for example, Microsoft offers us something called Purview. So this is used to configure security compliance requirements at the top level, rather than going to every individual data source and configuring things at that level. Okay, so enough about the old stuff, and a quick overview of the new stuff. How do we handle it? How do we implement it? So we talked about big data, volume, variety, velocity, real time. So how do you practically implement all of that stuff? So Microsoft offers us with lots of options. And here I've listed only the 3 most popular options. So we do have some other options as well, which I haven't listed here. For example, we have HD Insight. We have Azure Analysis Services, but no, the most popular options that are used these days, they are these 3. And if you want a recommendation, I cannot give you a recommendation unless and until I ask you lots of questions. So if you're saying, hey, we have 3 options, which one I should use? I need to know your background. I need to know your organization. I need to know how you're doing things. So that is where you need to understand all of these 3 options. And then after that, decide, okay, this looks better for us. Let's go with this one. So let's talk about these options one at a time. Let's start off with Azure services. In fact, if you do want me to mention my personal kind of opinion, this is typically 1. In fact, there's a tie. It will be very difficult to recommend whether you should only use Fabric or Databricks. They are very close. Fabric is definitely more powerful, as in it has lots of variety available. And then definitely the least sort of popular as far as these 3 is concerned is this one, Azure Services. So still, let's discuss all of these one at a time. Okay, so option number 1, use Azure Services. So use the existing Azure services to create your engineered data. Engineered data means your original data, you need to consolidate it, combine it, ingest it, load it into your single source of truth that represents your organization. So you're engineering the data by creating your data pipelines. So option number one, where you're using only the Azure services, would involve Azure Data Lake Storage, ADLS. So ADLS is where you can store your files. So you can store any kind of file like CSV. You can have your Excel workbooks. You can have even the modern format called Parquet and whatnot in your Azure Data Lake Storage, ADLS. And formally we call it ADLS G2, generation 2. You can also have your SQL Server database acting as your source kind of transactional database. So usually we use the term transactional processing or online transactional processing for this purpose. So we have this OLTP, transactional database. Every time you insert, update, delete data, this is where you will end up manipulating the data. And then this can be used, Azure Synapse can be used as your warehouse, where you're going to consolidate all of your data. And what service can be used to move the data from one point to another? Like you can have multiple CSV files, multiple Excel workbooks. You want to load it into your warehouse. Likewise, you have your SQL Server data, and you want to move the data into your warehouse. So the data movement is done by using the service called Azure Data Factory. So Azure Data Factory is basically the pipeline designing tool. And in fact, here on this diagram, this is the Azure Data Factory pipeline, which can be used to get data from any source of your choice and then load it into your Fabric environment or any other warehouse kind of environment, such as, let's say, Synapse. If you use this technique, your main issue will be administration. Lots of administration is required here. So your Azure administrator will be responsible for interconnecting all of these technologies. So all of these technologies, they need to be interconnected. So your Azure administrator will end up spending not hours, but days, several days of work will be required to integrate all of these technologies. And once it's integrated, yes, you can start using it. And if I just briefly point out this practically, so here I have my Azure Synapse open, and overall it lets you add different technologies, like your SQL Server databases can be added here. You can even choose to add a Python specific tool as well. So if you're a fan of writing code in Python, you want to create your Jupyter notebooks and whatnot, Synapse lets you add it. Should you use it these days? I would suggest don't worry about it. Don't use it these days, because I'm going to move on to option number 2, which is a lot better, superior compared to this option. Okay, so the second option, Microsoft Fabric. Fabric is a unified data platform. This ideally should be your go-to solution these days. If you have any of your data needs, you want to, let's say, use Power BI. You want to create your warehouses. You want to utilize machine learning. You want to use data science options. You want to write code in Python. You want to write code in SQL. You are a basic user. You are an advanced user. Doesn't matter what your role is. This should ideally be your go-to solution these days. So it's a unified data platform. In fact, it even contains AI features as well. So there are built-in AI services available. You just need to fine-tune them according to your data, and then you can start using them. So any role can benefit from it. Data engineers, data scientists, data analysts, machine learning engineers, every role can benefit from it. And Fabric, basically lets you store any kind of data. So you can have your SQL Server data. So if you want a SQL Server database, it lets you create it. You want to create your warehouse where you can centralize, organize your data, it lets you do that. So for that, we have warehouses or data warehouses. You are a more power user, you want to write code in Python. Let me actually quickly write it down here. So if you are only a SQL sort of user, data warehouse will be an easier option if you're only a SQL query type of user. If you want to use SQL plus Python, you want to create Jupyter notebooks. You want to use all of the Python specific libraries like pandas. You want to use data frames, Spark data frames. You want to use matplotlib, Seaborn. You want to use machine learning like scikit-learn. You want to use other advanced options like TensorFlow, Keras, PyTorch, etc. Lakehouses will be a better option. This is a more powerful option if you plan to utilize almost any kind of language like SQL, Python with different frameworks and whatnot. And then we also have real-time data support in the form of event houses. So event houses wise, we use something called Kusto query language, which lets us utilize real-time data. So we have the support for just SQL, for SQL plus Python, plus even for real-time data as well. And let me briefly show you these options here. So since we have less time left, and we do have detailed courses where we talk about all of this stuff in great detail. But overall, you can see that I'm using Power BI, but in reality, it is Fabric. So every, or not every, depending on your license, depending on your subscription, you will have access to just Power BI, or you will also have access to Fabric as well. So in my case, I have access to Fabric as well. And I have created a data warehouse. So each data warehouse is nothing but just an analytical database where you're able to create your tables, organize your data in the form of tables, and you're also able to write code in SQL format as well. Okay, let me double check if it's the right one. Ideally, I should have a bunch of tables here. Apparently not in this one. Okay, so second time lucky. So here I have a bunch of tables, and you're able to write code in SQL the way you're usually familiar with. So you can write the code in SQL. You can perform insert, update, delete, create views, functions, store procedures, and whatnot. And 90% of the SQL code that you're aware of from SQL Server works as it is. But yes, there are some differences as well. You can use partitioning, you can use bucketing for performance improvement and whatnot. But overall, if your goal is to access your analytical database by writing code in SQL, then this is the easiest option called data warehouse. Whereas the second option is called lakehouse, and lakehouse is more superior. So if I go to my lakehouse here, lakehouse lets you use your same SQL sort of syntax. So I can switch to the SQL endpoint here, and it will still let you use the same SQL syntax to access your data. But in reality, all of this data is stored not in the standard SQL format, but instead in the, let me show you the format here. So it's stored in the Parquet format. And to be more precise, we call this overall format Delta Lake, which has the support for transactions. You can use insert, update, delete, etc. by writing code in Python. So I can open up my existing, let's say, Jupyter notebook here. Maybe I can use this one for now. So you can create Jupyter notebooks here, write code in Python, and manipulate the data which you have in your lakehouse. So lakehouse is typically a bunch of Parquet files. Overall, we say that it is Delta Lake format, which has a support for transactions like insert, update, delete by writing code in Python. You can do all of this stuff. So here we have the Spark technology utilized here. You're able to load the data, clean it up, shape it, transform it, and whatnot. And all of this stuff is running in Fabric. So if you say that I'm an advanced user, I'm a data scientist, I'm a machine learning engineer, I'm an AI engineer, you can use Lakehouse in that case. And you can still utilize your SQL queries as well to manipulate your data, create reports, and whatnot. And then we also have something called Event House. So if I switch to my example again, so here I have, let's go back to the workspace only. And then here we have real-time or event house concept as well. So event houses are real-time databases. And whenever data is inserted, updated, deleted, and whatnot, it processes that almost in real time. And these real-time databases, they support this very special type of dashboard called real-time dashboard. And if I maybe, as a quick example, open up my existing real-time dashboard. So it's using the real-time database. And when new records are added, it will basically end up showing the new record here. Maybe as a quick example here, I'm going to produce data. I'm going to use Azure Event Hub and just produce some dummy data. Okay, so I'm producing a dummy data here, and within a second or two, it will basically end up refreshing. I do have to make sure that it's set to the refresh mode continuously, continuous real-time refresh. Okay, now you should be able to see that data is retrieved within a second or two. So real-time databases are available as well, which you should be aware of as data engineers. So you can see that data movement is taking place now. I'm sending random data, and it's basically receiving it in real time. It is not polling for the data. It is receiving an event. So it is the publisher, subscriber, pub/sub concept, where data is received in real time. Okay, so in short, overall, you can see that we have traditional databases, we have data warehouses for SQL, lake houses for SQL and Python, and real-time data is there as well. And then as data engineers, be aware of all of these, and also know that for the data movement, for data ingestion, data cleansing, data shaping, we have lots of options available to us. But the most powerful option is known as Azure Data Factory. So if I search for data factories here, I already have my Azure Data Factory service configured. And when I open it up, you'll notice that I have data pipelines here that can get data from different data sources, clean it up, shape it, transform it, and then write it to the destination as well. So here I have a bunch of pipelines. I can maybe open up this one for now. And you can see that it's able to connect to a bunch of, let's zoom in a little bit, fit to screen. So it's able to connect to as many data sources as you want. You can join the data, you can clean it up, you can filter out the data, you can perform lookup operations, and then eventually write the data to your destination as well. So overall, this technology supports lots and lots of sources and destinations. And as a quick example, I can just point out that if I, let's say, click this new, you can see that you can connect to any of these services. You can connect to AWS services, your on-premises SQL server. You can connect to CSV files on Azure or in Fabric. So every data source that we typically have to rely on is listed here. You can even connect to Jira as well. So any of these can be added as a source as well as a destination as well. So this way you're able to clean up the data, modify it, transform it, add columns, and then write it to your destination warehouses and whatnot. So as our data engineers know that there are lots of data sources available, real-time, Fabric, Lakehouse, Warehouse, Event House. and whatnot. And then you also need to be aware of the pipeline concept, so you can move the data from source to your destination. And then last but not the least, we have one more option here, and that is Azure Databricks. So some companies, they only want to utilize, let's say, Python or maybe Scala, or there are a couple of more languages. So if you want to mostly rely on coding and you want to use this popular third-party option called Databricks, but hosted on Azure. So Databricks, it's a third-party service, and you can have it hosted on Azure. Then almost any role can use it, but you need to write code, scripts. They have to be written in Python or Scala or R or various other languages. So if you are a programmer primarily, and you still want to do all of these things, you can choose to go with the Azure Databricks option. And this Azure Databricks service, when you do create your data warehouses and whatnot, these can be easily accessed from Power BI just because you're using Azure Databricks. So Microsoft, they have modified this Azure Databricks service so that it's easy for us to integrate with Power BI reports and various other services as well. So overall, this Databricks option is available as well. And if I just briefly show you here, where is my Databricks? So this is my Databricks environment hosted on Azure. And overall, if you're familiar with Python, you have used maybe Databricks before or Spark before, we have all of these concepts available. But the same concepts are available in Fabric as well. So even Fabric supports these concepts. So like I showed you briefly in Fabric, in Lakehouse, you can still write your code in Python. So Lakehouse is like Databricks. Plus, on top of it, it lets you store or write your queries in SQL format as well. So if I briefly open it up again, I even have machine learning, AI, machine learning, data forecasting, etc., and whatnot. So we have all of the machine learning concepts available as well, even in Fabric. So Databricks is primarily Python, or let's say R or some similar language-based technology. Otherwise, if you are looking for a unified data platform that's easy and at the same time it's advanced as well, you have lots of options available to you. Easy option, advanced option for data analysts, for data engineers, for data scientists, machine learning engineers, then Fabric will be a more superior platform. It contains everything. Okay, so in short, for now, know that data engineering, it has evolved a lot. It has become quite complex because of the need, like velocity, variety, and volume. So we need to be aware of some of the newer concepts. And then now we have different tools available or different services available. So be aware of the high-level concept of these three services. And we do have lots of detailed courses on all of these concepts if there's any need for any training. All righty. So any questions regarding the session? And over to you, Anne. So you can maybe just
Yeah.
course list
There we
again.
go. Yes, thank you so much, Fahim. And I am going to just put something in the chat here for everyone. If let's see, did I do that? Oops, hold on. Sorry. Did that good? I don't think it went through. Hold on. Sorry, guys. Try this again. There we go. All right. So I know, Fahim, you were talking a lot about some Azure, some Fabric, and these are courses that will follow on to this webinar. If you're looking for some hands-on, a little bit more in depth, the only thing better than 1 hour with Fahim is, 3 days of hands-on courses with Fahim. So I've put some in the chat here, but you're going to get an email in the next 2 days with this video recording, and we'll have all the classes on here and other resources for you as well. But Fahim, did you want me to show the website? Is there anything you wanted me to show in the Microsoft section?
I think just these links should be enough.
Oh, okay. Okay, great then. All right. Let's see if we've got any questions. I'm going to just look here in the chat. If anyone has anything, just feel free to ask away. Otherwise, you know where to find us. All right. I think you explained everything so well. I don't see any questions. Do you see any? I'm not seeing any on my end.
Correct.
Okay. All right. All right. Well, Fahim, thank you so much for doing this webinar. Thank you everyone who joined us and stayed for the whole time. Yeah, I know Fahim is very busy at creating custom content for clients. So thank you for taking an hour out and giving us all this
Happy to
great
help.
info, Fahim. Thank you so much. And thank you all to everyone who joined us.
Thank you, everyone.
All right. We will release you out into the world then. And oh, you're welcome. We hope to see you next time on a webinar, and we'll be in touch about the next one that we'll be putting on for you. Okay, thanks everyone. Bye.